Morning to all the students. As I have seen, approximately 40 students have been joined till. So number is increasing. Pramod, good morning. Okay. So I am just going to share my screen first, and then let me know whether the screen is visible or not. Aditya, is my screen visible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, good. So yesterday we have started our talk. Okay, first of all, you tell me yesterday whatever are you taught in the class. Have you gone through all the things or not? First of all, tell me. Have you revised all these things? Yes.
सर वो स्टैटिक सेंसिटिविटी आप बताना भूल गए.
ओके, बता दूंगा मैं. स्टैटिक सेंसिटिविटी
निकालते कैसे हैं ये भी जानना है.
क्या?
निकालते कैसे हैं ये जानना है.
उसमें कुछ नहीं करना, आपको ट्रांसफर फंक्शन लेना है, आउटपुट अपॉन इनपुट करना है बस. और क्या करना है उसमें आपको आउटपुट अपॉन इनपुट लेना है. नथिंग एल्स. उसमें बड़ी बात नहीं है ना. फिर मैं बता दूंगा, कोई बात नहीं. अगर नहीं बताया तो बता दूंगा. ठीक है, ओके. नहीं पता, बता दूंगा मैं, कोई बात नहीं. अच्छा, जो मैंने कल स्टार्ट किया था, जो बैकग्राउंड मैंने स्टैटिस्टिक्स पार्ट का, जिसमें रैंडम एरर वगैरह जो आ रहा था, वो आपने रिवाइज किया है कि नहीं किया, वो बताओ मुझे पहले. बोलो.
हो गया.
हो गया. तो तुमने मारो तुमने किया कि बाकी लोगों ने भी किया है? अबे बाबा ज्वाइन है कि नहीं आज? बाबा अगेन अब्सेंट. अनुराग.
यस सर.
कल स्टोरी चल रहा था, स्टोरी अब आगे बढ़ा कि नहीं बढ़ा?
हाँ सर, थोड़ा सा बढ़ गया.
बढ़ गया स्टोरी. कहाँ तक बढ़ा?
सर वो आप बता रहे थे कॉन्फिडेंस लेवल हम कैसे कैलकुलेट करते हैं.
तो वो सब कैसे करते हैं, ये कैसे किया भी है तुमने?
सर वो मतलब वही.
कैसे कंप्लीट होता है?
हाँ सर, मतलब मीन की वैल्यू निकालते हैं, वो मतलब एक्यूरेट वैल्यू के कितना क्लोज है वो हम देखते हैं, और उससे कॉन्फिडेंस लेवल का पता चलता है, और उसको हम मेजर करते हैं स्टैंडर्ड डिविएशन या वेरिएंस के थ्रू.
ओके, ठीक है.
यस.
ठीक है. सृष्टि बंगा.
ये बता दीजिए.
हाँ माधव.
हेलो.
हाँ बोलो.
सर कि वो सेकंड ऑर्डर के बाद अगर थर्ड ऑर्डर में जाएंगे तो वो 1 माइनस टाउ एस बाई 2 प्लस टाउ स्क्वायर के बाद माइनस टाउ क्यूब आएगा ना.
किसकी बात कर रहे हो तुम? पेड़े की?
वो जो e की पावर माइनस टाउ से था ना, फर्स्ट ऑर्डर और सेकंड ऑर्डर.
ओके. यहाँ पर ये
थर्ड ऑर्डर में जाएंगे तो वापस माइनस टाउ क्यूब आ जाएगा ना.
ओके. नाउ लिसन, बहुत अच्छा क्वेश्चन पूछा है. और कोई क्वेश्चन है दिमाग में? यू वांट टू आस्क एनी अदर क्वेश्चन? प्रिया, प्रवीण, एनी अदर क्वेश्चन इन माइंड?
सर एक और सवाल है.
हाँ.
मतलब वो जो टाउ तो है टाइम का फंक्शन है, और जब हम वो निकालते हैं e की पावर माइनस टाउ है तो वहाँ हम टाइम को s में चेंज करके निकालते हैं. तो सर यहाँ पे तो मतलब टाइम का भी ये है, फ्रीक्वेंसी का भी है, तो हम लोग करना क्या चाह रहे हैं?
क्या क्या फिर से बोलना, समझा नहीं बात को तुम्हारे में, अच्छी तरीके से नहीं समझा पाया.
सर लाइक सर टाइम को हम चेंज करते हैं ना s की डोमेन में.
Tau is the time constant. Tau is the time constant. There is not exactly time. The unit is time. That is a time constant. वो constant value है. For any instrument that is a fixed. Right?
ओके.
Chalo, now we are starting our discussion. So yesterday we have started our discussion with the transportation lag. In the transportation lag, we have discussed whatever the transfer function, okay, how the transfer function may be derived with the transportation lag system. So in this particular topic, we have seen what is the significance of transportation lag, and such type of problem usually occurred in any chemical plant and any process industries where some delayed response will come in the picture. So what is the meaning of delayed response? Delayed response means when you are applying some input at the particular end, and after some time your response will generate it. If you are applying some input at t equal to 0, and after some time t equal to tau, that the time constant, this if you generated after a certain interval of time, then this is the this is a delayed response. So when it will be represented in the form of Laplace in the signal system type signal equation, then you can write yt is equals to nothing but the xt minus tau. Yt is equals to xt minus tau, right? And what is the value of tau? So what is the tau? Tau is nothing but the time constant. So it is calculated with the help of AL by Q, that is the volumetric flow rate. Q is the volumetric flow rate, it is the meter cube per second, and this is the volume. So it will, when we will divide the meter cube per second, then it will give the time constant. So based on this, we have discussed, we have determined the Laplace transform of this function e to the power minus tau s xs. Then we have derived the transfer function ys upon xs e to the power minus tau s, right? So this is the transfer function for the any delayed system. So always remember, if your system is first order FOPTD, first order plus time delay system, FOPTD, it means it is the first order plus time delayed, क्योंकि दोनों चीज साथ साथ चलेगा. अगर let's say this is a tank process and we are supplying some input, so usually it will take some time in generating the response, right? And any system is generated with the help of some delayed response, and therefore the transfer function of such type of system, it becomes like this. This is the k upon 1 plus ts is the first order system. As you know, k upon 1 plus ts is the first order system. There's no doubt, I think. Now when you multiply with the e to the power minus tau s, it becomes a delayed response. So it means it is the delayed response of the first order system. Delayed response of first order system. In similar way, we can represent the e to the power minus tau s upon omega n square s square plus 2 zeta omega ns plus omega n square. So it will represent a second order delayed system. Okay. Now Madhav has asked one question, but wait for a minute. I will give the answer of that question also. So after the confirmation of the transfer function of the transportation lag system or the delayed system or the dead time system, we have approximated this transportation lag term e to the power minus tau s with the help of some mathematical tools, some mathematical equation, or some mathematical simplification. So if we can write e to the power minus tau s equal to 1 upon tau s, or when we expand this equation, okay, with the help of the series, then we can write, when we approximate to the first term, then we can write e to the power minus tau s equals to 1 by tau s. So again remember, when I'm talking about the first order plus time delayed system, so first order means k upon 1 plus tau s, right? And if the delayed system is given e to the power minus tau s, now you can know, if you are approximating the equation, approximating the system, then again you can write it 1 upon tau s into 1 upon 1 plus tau s. Am I right? So overall it becomes the second order system. right? If the time constant of both are different, then you can write T1 and T2 so that you can differentiate, you can discriminate the time constant, right, of the system. Then we have discussed the other approximation using the some mathematical simplification, and you can see here, you can see with the help of this picture, this line, this equation, e to the power minus tau s is nothing but you can write e to the power minus tau s by 2 into e to the power minus tau s by 2, right? And when you can write e to the power minus tau s by 2, when you take in the denominator, it becomes a positive sign, e to the power tau s by 2. Just expand it and approximate of the first order. Then you can write the equation e to the power 1 minus tau s by 2 upon 1 plus tau s by 2. However, when you take the second order approximation, then it will come to the second order system. Now the question asked by the mother, he asked, sir, can we expand to third order? Exactly, yes, but there is no need of expanding this equation. Why? Because when you're talking about the system, when you're talking about the any control system, always remember either the system is the first order, or the second order, or the higher order. What do you mean by higher order? Higher order means above or equal to the third order. Third order से start किया जाए, है ना, और उसको greater than or equal to third order system. Greater than or equal to third order system, right? You can write like this: greater than or equal to third order system. Higher order का मतलब ये. Now, the important point is this one: when you're talking about the first order, second order system, or the higher order system, this higher order system may be, represented or may be deduced into the second order or first order system only. Second order or the first order system only. Now, why it is happen and how it may be deduced? The higher order system can we deduce the higher order system into second order system or the first order system? Approximately, answer is approximately yes. Answer is approximately yes. Maybe no, but answer is maybe yes. So most of the if your system is a higher order system, then the calculation and the complexity for the computation system, for the computation becomes very high, very high. So therefore we are trying to deduce the higher order system into the second order, the first order system, with the help of some approximation. So one technique is there in the control system, and this question has been asked in the GATE examination, and the technique is the technique name was there is a pole करके है कोई I have not remember the name exactly right now. I'm not able to recall this term.
Dominant pole.
Dominant pole. Yes, very good. Who is this? Pramod. Very nice. Dominant pole. So what happened in the dominant pole? Can you tell me what is the dominant pole?
यस सर, क्योंकि सर जो पोल हमारा जियोमेट्रिक एक्सिस के पास होता है ना, उसका टाइम कांस्टेंट बहुत ज्यादा होता है, तो उसको हम डोमिनेंट मान लेते हैं एज कंपेयर टू जिसका टाइम कांस्टेंट काफी कम होता है. तो एक रेशियो होती है, अगर दो टाइम कांस्टेंट का रेशियो अगर मोर देन 5 हो, तो हम जो जियोमेट्रिक एक्सिस के पास होता है पोल, उसको हम अपना डोमिनेंट पोल मान लेते हैं.
ओके.
और अप्रोक्सीमेशन तैयार कर लेते हैं डीसी गेन को सेम रखकर.
वेरी नाइस. आपने कहाँ पढ़ा ये?
तुझसे
पढ़ा ऐसे पढ़ लिया कि कहीं कंसेप्ट आया था?
सर बीसीक्यू की बुक होगी सर, एक उसमें पढ़ा.
वेरी गुड.
बीसीक्यू की बुक है सर, उसमें पढ़ा.
यस ये बीसीक्यू और नागरत एम गोपाल दोनों में दिया रखा है. वेरी गुड. तो डोमिनेंट पोल कांसेप्ट इज देयर. वेरी गुड. So we are approximating the system into the second order system and the first order system with the help of dominant pole. So what happens in the dominant pole? Let's say I'm giving a simple example, okay, because most of you will not able to understand it because this topic has been not covered in your class. However, let's say there's a one pole is this one, and let's say one pole is standing here, and the distance between the two poles is the 5 times from the from this value. Okay, so if the it is stability of the system, it depends on your position of poles, right? Position of poles. As your poles is lying in the left hand side, let's say 1 upon s plus 1. 1 upon s plus 1, it means your pole is lying at s equals to minus 1. S equals to minus 1. Do you know BIBO system? Anyone? Bounded input, bounded output, the stability is found with the help of this techniques. Anyone? No. So
ये सर जिसमें कर्व क्या होता है कि कर्व बाउंडेड होता है, जिसका एरिया बाउंडेड होता है उसे बोलते हैं।
नहीं नहीं नहीं, ऐसा नहीं होता, ऐसा नहीं होता, कोई बात नहीं।
जिसका इनपुट आउटपुट फाइनाइट वैल्यू होती है।
Yes, yes, अच्छा, very good. So when your input is bounded, the output should be bounded. It is a generalized, you can say it is a generalized definition for the stability. So right now most of you are not able to understand it, but no problem. हाँ sir. Hello. हाँ sir. So some of your work is also coming in between them, no problem. So I think most of you are not able to understand right now, but after some time you will able to understand it. Okay, भैया अभी मैं क्लास में भी करता हूँ. So BIBO system is here. So no problem, I am leaving just things right now, but the meaning of the dominant verb, as your pole is lying in the left hand side, your stability is, let's say, what is the curve of this one? E to the power minus t. E to the power minus t means like this. Okay, so when you are applying the response at the t is equals to infinite, when you saying, just listen very carefully, at the t is approaching towards infinite, your response is tending towards 0. Your response is tending towards 0. It means system is stable. However, if let's say if your s plus 1 is there, if s plus 1 is there, it means it is your s minus 1 is there. S minus 1 is there, then it means your pole is lying at s equals to plus 1, e to the power t. E to the power t means your graph is going, your response is going like this. So at t tends towards infinite, your response is also not bounded, that is in going towards infinite. Therefore I am saying this is not stable, right? So let's say I'm taking 1 upon s plus 2, which means s plus 2 means s is equals to minus 2. So when you compare these things, s is equals to minus 2, it is far, it's the tending towards the response approaching towards the infinity is more steepest than s plus 1. And therefore we can say that as we are going towards the left hand side, your stability is increases. Your pole, as your pole is going toward the left hand side, your stability is increases. Now let's say your pole is s plus 100. It means your pole is lying at the s plus 1, and let's say one of the system is s plus 1, so it is like at the minus 1 and minus 100. So this is the transfer function of any, let's say, any system s plus 100 and s plus 1. So it means it is already stable. This pole is already in the stable system, right? So it is the what, which one is to analysis किसका करना है आपको? For which pole you want to analysis only? Okay, that pole is only s equals to minus 1. S is equals to minus 1. S is equals to minus 100 is already, you are assuming that you are, it is not, you are sure that it's more stable pole. Okay, so that which one is the note more stable? That is s equals to minus 1, and therefore we can approximate the system at a 1 upon s plus 1, right? This is a second order system. See, this is a second order system, but we can approximate it at the first order system. How? Because due to the dominancy of the pole is only for the s plus 1, not for the s plus 100. S is equals to minus 100, right? Now, there's a one question that is coming in my mind. Let's say the response is coming like ut. Your response is coming like ut. So it is neither, going towards the, as t tends to infinite, your response, let's say this is the response of any system. Okay, so as t tends to infinite, let's say your system response is 1 by s. So how do you the representing the pole? So the pole is at s equals to 0. Pole is lying at the s equal to 0, right? And when pole is at s equal to 0, so tell me what happened at the t is equals to infinite? Rajiv, can you respond?
Yes, sir.
What happened
Yes,
at t
sir.
is equals to infinite for this such type of system? Can you say this is a stable or unstable?
सर ये जो आपने यूटी लिखा है इसका बताना टी इक्वल टू इनफिनिट
Sorry?
यूटी फंक्शन आपने बनाया ना
हाँ,
सर इसका टी इक्वल टू इनफिनिट पे
तुम देखो क्या कर, मैं जो सुनते ही नहीं उसका मतलब मैं जब बार बोलता हूँ
नहीं
क्या
सर सुना तो है सर
सुने हो
सर
तो बताओ। I don't
सर अगर
understand.
1 बाय एस है तो इसका पोल 0 पे होगा
ये तो मैंने
सर
डिजाइन कर दिया, अब आगे बताओ। What is comment on the stability, राजीव?
सर स्टेबिलिटी के बारे में नहीं पता
जी, अभी तो बताया मैंने। शिल्पी, what is your comment? मुझे सुनते भी नहीं है लोग यार, मुझे तो ऐसा लगता है ना आप लोग सुनते भी नहीं हो। बोला जा रहा हूँ 1 घंटे से, बताओ। Why I am wasting? शिल्पी, respond. विकास राजोरा, विकास राजोरा, वितेश, बताओ। ये तो हाल है क्लास का। सूरज बिस्वाल,
Yes, sir.
बताओ कुछ आंसर दोगे? Do you want to give the answer?
No idea, sir.
What are you asked? First of all, tell me what is the question?
USZ.
Huh? What is the question?
सर वो फंक्शन का सर पोल बताना था।
अच्छा, फंक्शन का पोल बताना था। वेरी गुड। सूरज,
यस सर।
क्या बताना है?
सर
What is the
स्टेबिलिटी
question?
बतानी है उसकी। सर ये फंक्शन अनस्टेबल रहेगा क्योंकि इसका जो एरिया है वो इनफाइनाइट आ रहा है, मतलब
एरिया।
हाँ सर, मतलब जब e टू द पावर t था तो
जैन
उसका
साहब,
एरिया
जैन साहब, समीर जैन साहब,
यस सर।
हाँ, क्या पूछा गया?
सर वही कि फंक्शन अपना स्टेबल है या अनस्टेबल है।
ये फंक्शन तो मैंने पूछा ही नहीं है, तुम लोग कैसी बात करते हो यार? तुम लोग ठीक से
मतलब
करेक्ट वर्ड यूज क्या करो यार एटलीस्ट।
सर सर
हाँ प्रमोद।
सर फाइनल वैल्यू थ्योरम लगा के देखे तो इसकी वैल्यू 1 आती है इंफिनिटी पे, तो स्टेबल होना चाहिए।
पहले ये बताओ कि ये मैंने पूछा क्या, क्वेश्चन को कौन डिफाइन करेगा?
मार्जिनल स्टेबल होगा सर।
ओके पंकज, who will tell the correct question first of all? Tell me. Anyone in your class?
तो t इज इक्वल टू इनफाइनाइट पे सिस्टम का रिस्पांस बताना है।
सॉरी, फिर से बोला बबलू।
सर t इज इक्वल टू इनफाइनाइट पे सिस्टम का रिस्पांस बताना है।
Yes. So it is not function, it is system. I am saying system because you have, let's say, let's say applying some delta t, and in the response already delta t is there. So your response generated by t is equals to ut, nothing else. Or let's say if your response is ut, if your response of the system is ut, it means your pole is lying at the s equals to 0. And now my question is, what happened at t is equals to infinite? What is the response to t is equals to infinite? So your answer is, as Pankaj and Pramod have said, sir, it is bounded because at the t is equals to infinite, the value is constant, 1. It is not going towards the t tends, it going towards the zero value. It is not approaching towards the 0 value. The response is not tending towards the 0 value. Am I right? If it is not, tending towards the 0, but it is also true at the same time, it is not tending towards the infinite value. It is not tending towards the infinite value. As we have seen it n to the power t. As we have seen it to the power t. So what it means? It is not tending towards 0. The response is not tending towards 0, not tending towards infinite. If it is tending towards 0, then system becomes stable. However, if it tending towards infinite, the system becomes unstable. So what it means? It means the system is marginally stable. Marginally stable. Marginally stable. So it means now you can understand it. At when the pole is at equal to 0, s equal to 0, the pole is at the origin, lying at the origin, system becomes marginally stable. When your pole is lying in the left hand side, the system is stable. When your pole is lying in the right hand side, system is become unstable. So as you are going towards this side, your system becomes stable, more stable and more stable. Is it clear? Is it clear? So this is the case for the bounded input and bounded output, right? First is the criteria for the bounded input and bounded output, and second criteria, as t tends to infinite, your response must be tending towards 0 or infinite, or finite. If the response is finite, then it means marginally stable. If it tends towards 0, it means system is stable, absolute stable. Any doubt? Any doubt? Yes or no? Tell me.
No, sir.
Okay. Can you proceed further?
Yes sir.
Yes, sir.
Okay. चलिए.
सर मेरे को इमेजिन नहीं हो रहा, मतलब मैथमेटिकली तो ठीक है, लेकिन अगर सोचे कि क्यों हो रहा है तो ये मेरे को क्लियर नहीं हो रहा. मतलब
क्लियर होगा जब क्लास में, जब हम उसको डिटेल में देखेंगे तो क्लियर होगा. But I have also constant because I'm not teaching the control system right now, Madhav. So I will try to cover all these things, but it will take some time, right? So when we talk about the stability of the system, 100% I will cover there. But mathematically, just to try to understand it, it will happen, right? But when we take the physical system and when we interpret from that physical system and we'll try to find out the stability of the system, then only you are able to understand in more better way. I can understand it. but we have also some constant, है So okay, I'm leaving this. So now you can understand now why we are not going towards the higher second order system. Okay, because we can approximate any higher order system into the first and second order system, and is more convenient for us for the computational to avoid the computational complexity. Now, when coming to the next part, that is very important, and I think in the revision we have taken the half an hour. Okay, so we have only half an hour, and okay, so calculation of overall systematic error, right? So calculation of overall systematic error, we have seen the different types of, the systematic error, how it is calculated overall due to the different component. So component may be due to the measurement, system loading, environmental factor, calibration error. We have taken this the component n component, and for the n component is let's say existing in the system, n component error is in the system, then we can calculate the maximum systematic error with the help of this formula. Okay, and then we have seen one example based on this. Then we have discussed the most important. We have tried to develop our basic fundamentals for the standard deviation, why the standard deviation is used, and what is the significance of the median standard deviation, and different types of distribution, Gaussian distribution, right? So it is the basic fundamentals of the statistics tools used in the measurements, or you can say here it is in the measurement, or you can also say in the data science. In the data science, because it is very, very important statistics. Okay, so I will try to cover it in the full details of these topics, right? Because it is a very important tool. You need such type of tools for handling the large number of data or the a small number of data, right? So so this is the different types of noise, different types of random error comes due to the electric noise. These are the cause by which the different types of random error will occur in the system, and it is eliminated with the help of when you repeating our experiment, okay, and taking the average number of that, the average number of that measurement, then your result is closing towards the true value or the real value. Okay, so but the question was, we have discussed then, while the process of averaging over a large number of measurement, it reduces the magnitude of random error only. It is not completely eliminate the error, because your number of experiment is not infinite. Okay, as you take the number of experiment larger and larger and higher, okay, as you take the number of samples more and more, your accuracy will becomes more. If right, as your number of sample is less, okay, then your automatically your average value is not very real towards the real value. Okay, so it means the number of average value will not eliminate the complete random error, but 100% it will reduces the number of magnitude of the random error as you increase the number of samples or the number of measurement. You can also observe such type of things with the help of, you can see many of the at the time of the election, and at the time of the election, many of the opinion poll and exit poll will comes, and based on the opinion polls, number of samples taken by the reporters, and some statistical tools will applied on that samples, and then we can calculate that which party is going to win and which party is going to. But the accuracy of sample is depends on the number of measurements or number of samples what you have taken, right? So it is very important. So as the number of measurement will increase, it will automatically reduce the magnitude of the error, right? So for the zero error for the zero error, or if you want to find the correct value, so it means you have to take the infinite number of value. Infinite number value is practically it is impossible. It is not possible to take, but so it means that it reduces the magnitude of, we have concluded these things, reduces the magnitude of random error to a small value. Okay, a small value, but we are not able to make it zero, right? So it means now our next part, we have going towards the next discussion, that is the degree of confidence. So degree of confidence means whatever your closeness, whatever you got the results, okay, whatever the you have calculated the mean value, okay, so your mean value, it at what extent your mean value is close to the correct value. Okay, this quantification has been done with the help of standard deviation or variance of data. If you calculated the standard deviation or variance of data, you can see that your closeness, your extent of closeness, your mean value extent of closeness to the correct value. Okay, so this type of calculation is known as degree of confidence. What about your degree of confidence, right? So before going into the details of that, I hope it is now you are able to understand these things. So if you want to ask any query, you can ask. I'm waiting for the 1 minute. You can ask. Yes. Anyone? No.
क्लियर है.
क्वेश्चन नहीं पूछोगे तो इसका मतलब कि आपको सब समझ में आ गया या तो कुछ समझ में नहीं आया, है ना? Ask the question, give the challenge and take the challenge. If I will not able to give the answer, then I will go through and read the books, search the things, then I will give you the answer. That will help me in order to develop that skills. If I will give you some problems, if you are not able to give the answer, try to search this, try to solve that problem. Okay. Some are going to left the meeting. Okay. So I am starting our discussion with the, so ultimately you can write now, we can write now a more formal quantification of the degree of confidence in terms of standard error of the mean. So ये हमने अभी तक देखा है. अब डिग्री ऑफ कॉन्फिडेंस को कैसे मेजर करते हैं, आई विल गिव यू द 1-2 एग्जांपल, देन यू विल नाउ कंक्लूड. सी, सो देखो एवरेज वैल्यू जो है हमारा, एवरेज वैल्यू कौन सा एवरेज वैल्यू जो हमने अभी कैलकुलेट किया था, एवरेज वैल्यू ऑफ any set of measurement, let's say measurement of a constant quantity. Listen, very important distance. Quantity is expressed in terms of एवरेज वैल्यू. कैसे कैलकुलेट करते हैं? एवरेज वैल्यू ऑफ एनी सेट मेजरमेंट, लेट्स से कोई मेजरमेंट आपने किया, सो एवरेज वैल्यू, हाउ यू कैलकुलेट, हाउ यू क्वांटिफाई, विद द हेल्प ऑफ दिस टर्म. कैन यू टेल मी व्हाट द नेम ऑफ दैट टर्म? एवरेज वैल्यू इज कैलकुलेटेड विद द हेल्प ऑफ, टेल मी, What's the name? बोलो यार.
सर क्वेश्चन क्लियर नहीं हुआ, एक बार फिर से. एवरेज वैल्यू.
एवरेज वैल्यू जो कैलकुलेट होता है, कैन वी राइट?
सर एक मीन यूज करते हैं.
यस. सेकंड वन.
मीडियन.
मीडियन.
Mean and median. Right? Mean and median both are calculating, both are the terms used for the calculating measurement of the average value. Right? No, now median value, however, the median value was easier, quite easier. Right? Quite easier for a computer simulation. Why? Problem is why it is easier than mean, you can say. Why? Because median value is dependent on the logic operation. However, the mean value is depending upon the addition as well as the division. Right? So therefore, nowadays there's no problem because you have a very high-end computer, right? Very high-end configuration of the computer. So there's no problem right now, nowadays. But when it is proposed in the initial days, at that time the median value was more easier to come for the computer simulation as comparison to mean. So from that time, the median is in more convenient, and the publics are the scientists and the users are using. So therefore median is कह सकते हैं कि median जो है आपका बहुत ज्यादा प्रचलन में ज्यादा है, ठीक है ना, लोग ज्यादा यूज करते हैं इसको. There's no other reason behind why the median is using more than the mean. The significance of both the things are the same. Okay. Same, otherwise no problem in this. Okay. So now we will give the example. You can calculate the median and mode, then you can see what the difference is coming, okay, in between them. Okay. So as the second point is, as the number of measurement increases, the difference between mean and median values become very small, very small. Right? What it means? You now understand? If your number of measurement increases, number of sample increases, number of measurement increases, automatically the difference between the mean and median value becomes very small. Okay. Right. So however, you can say next line is, however, you can say the average calculated in terms of mean. Let's say in terms of mean value is always closer. You can say not is that closer, but you can slightly closer to the correct value of the measured quantity than the average calculated as the median value for any finite set of measurement. read the things once again. Read the line. However, the average calculated in terms of mean. Whenever you calculated the mean with the average mean, okay, so it is slightly closer to the correct value, okay. When then the average calculated with the help of median, okay. So where your measurement, your sample is less, your finite number of sample is less, then you will find the mean value is more precise. Your precise means more accurate, okay, than the median value. But it is when it will spread, the value number of samples increases, automatically it will go towards the median. Okay, so these are the things. Now, so the mean of the system is given by the equation. Let's say we have the n measurement. We have the n measurement from x1, x2, x3. These are the measurement. Xn of, let's say, of a constant quantity, so your mean, that is the x mean, is nothing but, as all of you know, x1 to x3 plus dot 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 up to the xn divided by n, right? Now what the median, how the median will come? The median, so median is an approximation.
Sir, the data is sorted.
Yeah, sorry.
The data is sorted in increasing or decreasing order. Sir, the data is sorted in increasing or decreasing order, and the data point which is in between is considered the median of the data points.
It depends on the logic, right? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so median is an approximation to the mean that can be written down without having to sum the measurement, right? जिसने सबने बोला, without any measurement, without any sum of the measurement, we can approximate the median value. Yes or no? Why? How the median value can be given? Let's say the set of n measurement. We have again set of n measurement is there. Measurement is there. Let's say x1, x2 to xn of a constant quantity, written in the constant quantity as Rishabh has told, written in the which order? Ascending order, right? What you have to do first? First, you have to write the sample equation, your data sample, in the terms of ascending order. You can do it in the Excel. Okay. So tomorrow I will try to just demonstrate with the example in the Excel also. Okay. So ascending order. First, you have what to do? You have to ascend. You have to just keep your data in the ascending order. Okay. Ascending order of the magnitude, and then you can calculate the x median. And how the x median will calculated? That is the xn plus 1 by 2. That is in between the whatever the value is in between them, right? So let's say your data is, let's say you have the, many of you have been asked the problem, sir. Let's say you have that is a fine when your data is the odd number, set of 9 measurement. Let's say we have a set of 9 measurement, then it's fine. You have to calculate the value. Okay, so what is your median? So your median is, it is very easy to say, it is x5. Median is x5, right? But now when your measurement is the 10 measurement is there, 10 measurement is there, x1 to x10, then what is the what is the median? What is the median? Can anybody tell me?
X5 और X6
नहीं, ये केवल माधव और सब बस नहीं रहेंगे, प्रमोद नहीं देगा। एनी अदर? इतने क्लास में अक्षय रावत साहब, ये सुनते भी नहीं है, मुझे तो ऐसा लगता है कि सुनते भी नहीं है सब। अर्शदीप,
सर उससे डिवीजन करके जो उससे नेक्स्ट एलिमेंट होगा उसको लेते हैं हम।
मैं 10 मेजरमेंट लिया हूँ, अब तुम मुझे बताओ क्या होगा।
एक्स एन 10+1/2 हो जाएगा, 10+1/2।
मैंने x1 से लेकर x10 तक
हम
डाटा
उसको
लिया है। मैंने x1 से x तक 10 तक डाटा लिया है। व्हाट इज द मीडियन वैल्यू? टेल मी
सर मीडियन मींस सेंट्रिक वैल्यू
और डिवाइड करके।
अरे बताओ ना क्या होगा।
डेटा को सॉर्ट कर देंगे, उसके बाद डेटा को सॉर्ट कर देंगे और x5 + x6/2 होगा।
x5 + x6/2 होगा, मतलब बीच वाले।
बोलो सिंपल यार, इसमें x5 + x6/2 खत्म बात होगी। इसमें इतना क्यों सोचना? Now I am coming to the next problem. Okay, I'm coming to the next part. That is your first question is here. Suppose that the length of steel bar is measured by a number of different observers, and following set of 11 measurement are recorded, right? आपका mm में यूनिट है। लेट्स से वी विल कॉल इसको, इस मेजरमेंट को हम ए मेजरमेंट कह रहे हैं। मेजरमेंट नंबर 1 ए, मेजरमेंट नंबर ए है ये, मेजरमेंट नंबर ए। रिकॉर्डेड कॉल है, रिकॉर्डेड वैल्यू है 398, 420, 394, 416, 404, 408, 400, 420, 396, right? 396 and then 396, then 413, then 430. This is the measurement set A, right? So what is the median? What is the mean? Can you calculate? You can calculate, na? Yes or no?
Yes, sir.
Yes, sir.
Everyone can calculate. Just to add this all the value and divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Already 11 measurement is given. So just to divide, you will get the mean C, 409.0. I am just demonstrating the things. Okay, what happened? When you calculated the median, what is the median? Just you can see with the help of this value and the 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This value is in between them. So you can say 408, right? Is it clear? Now you can see that there's a difference.
मीडियन के लिए तो सॉर्टेड नहीं होना चाहिए था। सॉर्ट नहीं करेंगे,
सॉर्ट करना पड़ेगा ना सर एक बार।
सॉर्ट करने के बाद ही 408 आएगा।
सॉर्ट कर लो, वही आएगा।
least to greater
आएगा वही।
असेंडिंग ऑर्डर में कर लो, 408 आएगा, कर लो, ठीक है ना? मैंने बीच में लिखा है उसको इस तरीके से। You can do. Your procedure is very right. You are saying the bilkul totally right? Okay. So no problem. When you keep in the ascending order, then you will get the same thing, 408, right? So my point is, you can see the difference between the mean and median. 408 is your median. However, the mean is 409.0, right? Okay. So for the median, it is very easy to say this is the median, sir. Just you have to arrange this one in the ascending order now. However, for this, you have to calculate this one. Therefore, we have discussed earlier, the calculation of mean is quite computational complexity than the median. Nothing. Median is a logical, based on the logical operation. Now, I am giving the second example. Let's say measurement set B. Measurement set B. Set B हमने लिया measurement का सेकेंड हमने मेजरमेंट लिया है, मेजरमेंट सेट बी। और नाउ वी हैव द experiment. You see the data 409, 409, 406, 402, 407, 405, 404, 407. Okay, then 404 again, then 407 again, then 407 again, and then 408. Okay, so based on this, when you calculate, mean will comes 406. However, the median will gives the 407. Right. So now my question is, which one have the most confidence? देखो दोनों में आप दोनों का जो आप लिए हो 1 2 3 4 5 6 7 8 9 10 11 11 मेजरमेंट यहां भी है, 11 मेजरमेंट यहां भी। In this case you got the mean 409, median is 408. In this case you got the mean 406 and the median is 407. So confidence level किस में ज्यादा है? Most confident कौन है? Which one is the most confidence?
407.
Most confident क्या है? Which one is the more reliable?
मीडियन में ज्यादा है, मीडियन
407. Right. It means we can say that we can regard measurement set B as being more reliable. Am I right? Yes or no? More reliable. Because why? Because measurements are much closer together. Yes or no? It is highly precise value. This experiment has a high precise value. 407, 407, 407, 407, 404, 404. It gives 2 times, 3 times. So it is a highly precise value, and therefore we got like this. The result is we got like this. Now I am taking the third experiment, and I will take 2 minutes more. If you are interested, then I will finish this topic. Okay. So let's say I have taken 23 experiments. Let's say we have taken the experiment number C, measurement C, measurement set C. And measurement set C, we have 23 measurement. Let's say 23 measurement है हमारे पास। और जरा देखो क्या है, तब आपको पिक्चर पूरा क्लियर हो जाएगा। Then you are able to say each and every things. Let's say we have the data 409, 406, 402, 407, 405, then 404, then 407, then 404, then again 407, 407, 408, 406, 410, 406, 405, 408, 406, 409, 406, 405, 409, 406, and 407. Right. These are the data, and this data has the 23 experiment. You can count it. When you calculate the mean, you will got 406.5. However, the median is now, median becomes 406. So what does it mean? Tell me. Whatever you conclude, what do you want to conclude here?
मीन और मीडियन पास आ गए।
क्यों आ गया?
क्योंकि नंबर ऑफ एक्सपेरिमेंट्स बढ़ गए।
Exactly. Very good. So it means this confirm this confirm our earliest statement? Yes or no? A statement.
Yes,
What is the statement? That the median value tends toward the mean value as the number of measurements increases. Yes or no? Am I right? Any problem? No, tell me. Is it okay?
Yes, sir.
So these are the things.
Yes, sir.
Yes, sir.
Okay. So by the tomorrow is your self-assessment quiz time. So I have not completed standard deviation and variance, but I will ask the question on the standard deviation and variance. So from next week I will start, because in the next week we will cover the single system, and by the next week we will start we will continue with the standard deviation and variance in the mechatronics subject, right? So tomorrow I will give the numerical based on all the things whatever I taught in this week, right? Based on but I will also
सर्कल हॉलीडे नहीं है।
सर्कल गांधी जयंती बनाना है, टेस्ट नहीं देना, देख लो।
यस सर
20 मिनट का टेस्ट अगर देना चाहो दे लो, नहीं देना चाहो ना तो इट्स योर चॉइस। मेजॉरिटी व्हाट विल से नो।
सर ज्वाइन तो नहीं करना होगा ना गूगल मीट से?
नहीं ज्वाइन नहीं करना, केवल आपको आप केवल आंसर आपको टाइम आपको दे दिया जाएगा, आपको टेबल टाइम बता देंगे
सर नेक्स्ट वीक कर लो।
हाँ क्या?
यस सर नेक्स्ट वीक
अभियान है
सर मैं भी
सर मंडे कर लो।
मंडे को फिर एक दिन टाइम खराब करोगे लेक्चर का? हाँ
तो छुट्टी पहले से डिसाइड कर लो,
या तो फिर क्लास के बाद मैं आपको दे दूं। क्लास डिस्टर्ब नहीं होना चाहिए ड्यूरिंग क्लास में। टेल मी दैट
सर अदर क्लास में होता है ना सर?
हाँ सॉरी ऋषभ
सर लास्ट 2 टाइम से नेटवर्क इश्यू का मेरा हर बार सब।
अरे कोई बात नहीं, बाकी लोग तो बताओ। हाँ डिसाइड करके मुझे बता देना। परवीन बता देगा मुझे क्या करना है, ठीक है? ओके चलो,
ओके सर,
बाय।